In this video, we're going to learn how to calculate the volume of the solid of revolution. Okay, so we're given that we have to revolve the region under a curve y is equal to square root of x on the interval from 0 to 4, endpoints included, about the x-axis, and find the volume of the resulting solid. So first I'm going to draw this function that we're given that defines a curve on the xy plane, and I would recommend you to do the same thing. Maybe I should do it here on the right side. Okay, like this. Okay, so I'm just going to label x, y. So I'm just going to use quadrant 1 because we're given from 0 to 4. So 1, 2, 3, 4. 1, 2 for the y. Okay, so we're going to plot the points. So when x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 1 as well, right? I'm just plugging values into this equation here to find the y. And then for 2 we get square root of 2, for 3 we get square root of 3, and finally for 4 we get square root of 4, which is 2, right? So this is about something like that. Okay, so the region that you will have to revolve around the x-axis, okay, will be this region here. So notice that it resembles a cone, and you might think, well, the volume, I'm thinking of the volume as pi r squared h. If you're thinking that, you're exactly right. So let's draw this okay, so we're thinking of this this solid, right? Now take a look at this. Notice that each solid, this solid can be broken down into cylindrical slices, right? Like that. Okay? Now each cylindrical slice will have thickness, and you can call it height of that slice, dx, right? Because I'm just plotting it, I'm pointing it the same direction that I drew it in the xy plane, right? So this is the x-axis, obviously, right? So the dx is going to be the height, and the radius that will vary for each slice, because there are infinitely many slices, will be square root of x, right? The y value. Okay? And it makes sense because square root of x will vary, okay? And according to the x chosen, right? So the square root of x represents the y, which will vary, and that represents the radius of each slice. And the reason why we're using definite integral is to sum up infinitely many slices that this shape can be broken down into, in order to avoid using the summation rules and taking the n to infinity, okay, the number of these slices, right? So I'm just going to say the dx is the thickness, height of each slice, and radius, of course, is going to be square root of x and y. So as you know, the volume of the cylinder is going to be pi r squared h, right? So using the same volume, we can determine the volume of this solid if we revolve it around the about the x-axis, right? So we're going to take pi. Well, let's have the integral. So integral from 0 to 4, because you're trying to sum up all the n slices and n taken to infinity, right? From 0 to 4. So that's why you're integrating using the definite integral from 0 to 4, and you're going to use the volume of the cylinder formula, pi r squared h, and r is going to be equal to square root of x. Okay, so square root of x must be squared in the formula, and then the h, as we discussed, was the delta x, dx, right? So it's just the thickness, the height of each individual cylindrical slice. So now we're ready. We're going to take the pi outside because it's a constant. So we're going to have x because square root of x squared is just x, and then dx. And now it's fairly simple because we're going to have to follow the power rule of the antiderivative. So we're going to have pi over 2 x squared integrated from 0 to 4. That gives us pi over 2. 4 squared is 16 minus 0, right? Because 0 squared is 0. And then that gives us 8 pi. Okay, so there goes your volume of the resulting solid of revolution. So I hope that you found this video useful. Please subscribe, and I'll see you in my next video.